This is the final part of my lecture on parametric statistics, in which I'm going to summarize some of the things that we've talked about. First of all, let's just have a look at some of the tools that are available. We talked about ranking tests, and there are tools available online to do these sort of tests. For example, there are tools at Vassar Stats for doing Wilcoxon's matched pairs signed ranks test and Wilcoxon's two-sample rank test. IFA Services also have tools for doing Wilcoxon's matched pairs signed rank test and Wilcoxon's two-sample rank test. The binomial test calculators are also available online. At GraphPad, you select what they call the binomial and sign test, or at Vassar Stats, binomial probabilities, or at IFA Services, binomial probability distribution. There are also calculators for doing chi-squared online. GraphPad can do one sample chi-squared if you select compare observed and expected frequencies, and it can do Pearson's chi-squared, but only for a 2x2 table, which is a bit limiting, if you select analyze a 2x2 contingency table. Vassar Stats can do the one sample chi-squared test by selecting frequency data and then chi-square goodness of fit test, or Pearson's chi-squared test. If you want to do a 2x2 table, select frequency data and then 2x2 table, or Pearson's for larger tables than 2x2, select frequency data and then chi-squared. IFA Services give the one sample chi-squared test under chi-squared test for known distributions, and Pearson's chi-squared selecting chi-squared test for equality of distributions. If you want to do Fisher's exact test, then you can do it in GraphPad for just a 2x2 table. At Vassar Stats you can do it for a 2x2 table, and also for a 2x3, a 2x4 or a 3x3 table, although it's very difficult to find anyone that can do a Fisher's exact test for anything bigger than that. I talked, when we were talking about experimental testing, about the power of tests, and if you want to work out the power of a chi-squared test, its ability to find a result if it is there, then you can use various calculators. DSS Research have available power calculators for a one sample chi-squared test if you select percentages one sample, or for a two sample test if you select percentages two sample. And Ruslan's PyFace applet, which requires the Java runtime environment to be installed on your computer, lets you do a one sample chi-squared test using test of one proportion and a two sample chi-squared test for tests comparing two proportions, and that's good for small sample sizes. It has some rather nice tools there. So summarizing what we've said in this lecture and in the previous lecture about tests to use, we can look at different comparisons and different sorts of data. So I've shown here in the first column what we can do if we have quantitative data that is normally distributed, where we can use a parametric test, or quantitative data that is not normally distributed, where we have to use a non-parametric test, or where we've got ordinal data that also requires a non-parametric test. And in the third column, if we've got categorical data that is nominal or ordinal, or we've got quantitative data that we can group into different categories, and that also needs a non-parametric test. So if our comparison that we want to do is to compare a single sample with a known population, then the parametric tests we looked at were the one sample Z test and the one sample T test, and the non-parametric tests we've looked at in this lecture are the Wilcoxon signed rank test for data that can be ranked, or the binomial test, or the chi-squared test for categorical data. If we want to compare two paired samples, for parametric data we've got the paired T test, or for the non-parametric equivalent, Wilcoxon's matched pairs sign rank test. I haven't told you about the test for categorical data that's paired, but it's called the McNamara change test if you want to look it up in textbooks. If we've got two unpaired samples, we saw that for parametric data we can use the two sample Z test or the unpaired T test, and the non-parametric equivalent of those are the Wilcoxon's two sample rank test or the Mann-Whitney U test, which is equivalent. If we've got categorical data, we've seen that we can use the chi-squared test or Fisher's exact test if the numbers are small. We also looked at analysis of variance when we're talking about quantitative data. That's used when we've got more than two unrelated samples. So the analysis of variance is the parametric test. The non-parametric equivalent of analysis of variance is called Kruskal-Wallis. I haven't talked about that, but again you can look it up if necessary. But if we've got categorical data, we've seen that the chi-squared test can be extended to any number of rows and columns, so that can be used for more than two unrelated samples. So I hope that this table points you in the right direction if you find you've got some data and you want to know the appropriate test for analysing it. So that's the end of my talk on non-parametric tests.